All right, are we ready? Now guys, trig, thank you. Let's focus please. Trig is actually the study of triangles. Trig always comes back to triangles, so you can write it on the side. Geometry is the study of shapes, right? Algebra is the study of numbers. And trig is the study of triangles. So we're going to be working a lot with triangles and sides of triangles and angles in triangles. Sometimes we're going to do stuff that's a bit different, but it all will be able to relate back to triangles. Okay. Now guys, in the beginning, it's going to seem very, the word that I'm looking for. It's almost going to feel like, why are we doing this? How does it link into things? I just first need to teach you the basics before we start applying it. All right, so just bear with me for a while I teach you the ratios, maybe tomorrow, or I do actually see you guys next week, Tuesday. I have my dates wrong. So maybe by Tuesday next week, we will get to the actual proper application of this, and then it should start falling into place. Okay, so for today, if you don't know what we're actually doing, don't stress. I just need to teach you the ratios. Now guys, ratio is we all know like 1 to 3, right? But when I'm talking about trig ratios, we're actually working in fractions. Okay, so we're going to put something over something. We all know that a ratio is the same as a fraction. So a ratio of 1 to 3 is the same as 1 over 3, essentially. Okay, so trig ratios, we're going to be working with this. Now guys, what is very important is that the trig ratios that I'm going to teach you today only work in right angle triangles. Okay, so we just do need to add that there. In grade 11, I'm going to show you how we can use trig in non-right angle triangles, but for now, only in right angle triangles. Just like pi side, right? Pi side we can also only use in right angle triangles. It's the same thing with these trig ratios. So in our triangle, I would like us to give a name to this bottom angle. I know that it's C, but let's say that angle C is equal to X. Now, if we're looking at this triangle, we obviously have 3 angles, and we remember that the 3 angles in the triangle have to add up to 180, right? So if we have a 90-degree angle and then X, what is this top angle A going to be equal to? Yes. Right? 180 minus 90 minus X. Can I simplify that? 90 minus X. Okay, I'm going to put a little arrow there. To calculate that angle, you would say 180 minus 90, because that's an angle that we have, minus X. Okay, so when we actually work that out, we can simplify that to 90 minus X. Okay, so when I'm going to refer to angle A, the side of angle A is 90 minus X. Okay, now this is now where we're going to introduce trig. Like I said, please don't panic. We are going to use it. We're going to apply it later on. But sine, which we just write sin, but we say sine of X.
It's just sin. It's not. I know you think.
I'm going to write it down literally in one thing.
No, I'm saying so you can start. But it's
It's I ended. You never have to spell it out, Jonathan. You just write this. Just write it as SIN. Okay, so the definition of sine of any angle. So we're doing sine of the angle X, but we can also do sine of the angle 90 minus X. Okay, later we're going to talk about these trig ratios of 90 degrees. So now we're just going to work with these angles that we have there, the X and the 90 minus X. The definition of sine is opposite over hypotenuse. The opposite side over the hypotenuse of the triangle. All right, so this is saying sine of X. So sine of the angle X. So we're looking at angle X. Which side is opposite angle X in this triangle? AB. So we're going to say AB over, what is the hypotenuse of this triangle? AC. Do we remember the hypotenuse is always opposite the right angle? Okay, so AB over AC. That is sine of x. Sine of this angle. But I can also find sine of the other acute angle, sine of 90 minus x. And then I just put it in brackets just to show that that is actually one angle. And now we're going to look at 90 minus x, this angle. Now we're going to say, what is the opposite side to 90 minus x? BC, this thing is good. BC over opposite over hypotenuse always, guys. This formula is never going to change. Okay, sine is going to be opposite over hypotenuse until you are 85 years old or whatever, all right, forever. So opposite of 90 minus x is BC over hypotenuse is AC. Like I said, we're just practicing the formulas. We're going to apply them later on. Yeah.
So the sine is the 90.
But we're not going to go into that now. This is practicing. We're not going to. We're not going to talk about the 90-degree now. We are going to use it later on. Okay, so don't stress about that. We're just doing the acute angles now. So that's sine, guys. All right. The other one is cos. So cos of x. Cos of x. Again, we're going to look at x. Sorry, I should actually just write down the formula first. This one is adjacent. You know, do you guys know what that word means? We'll talk about it now. Over hypotenuse. Adjacent means next to. All right? So for cos, we're always going to take the side that's next to the angle over the hypotenuse. Now, guys, if we're looking at angle x, technically BC and hypotenuse, both of those are next to angle x, but the adjacent side can never be the hypotenuse. Okay, the hypotenuse is just AC, and it's just the hypotenuse. All right. So the adjacent side is going to be the other one that's next to it, which is BC in this case. So we're going to say BC over AC. Okay, so the hypotenuse is the hypotenuse, it can't be anything else. So that's cos of angle x. Let's do cos of 90 minus x. We're going to use the same definition. Cos is always adjacent, the adjacent side over the hypotenuse. And we're looking at 90 minus x. The adjacent side is now the one that's next to it that's not the hypotenuse. Okay, so AB over the hypotenuse, which is AC. Yeah. No, I don't.
How do you know which one?
Okay.
How do you know which one?
No, that's why we don't do it.
Right now. How do you get that?
So if you're looking at the angle, there are two lines lying next to it, next to that angle. So the hypotenuse is the hypotenuse. So the adjacent side is going to be the other one. All right, then we have, maybe I should just make a little star here, sorry, to show that that is one. This is another one. Then we have tan. You guys have heard of this. So tan is different from sine and cos. Guys, if you notice that with sine and cos, both of them were over the hypotenuse. The sine was opposite of hypotenuse, cos was adjacent over hypotenuse. Tan doesn't include the hypotenuse at all. Tan is opposite over adjacent, yes. If you did put them in I wonder if you does that. I suppose, yeah, it's the same thing, I guess. All right, so opposite over adjacent. Thank you. If we're looking at x, the angle x, are we going to see? Then the side that's opposite angle x is AB. The side that is adjacent to angle x is BC. So tan of x is going to be AB over BC. Then we can also do tan of 90 minus x. Guys, it is important that you put that angle in brackets, because if you don't, then it's going to read differently. It's going to say tan 90 minus x as two separate terms. Okay, so you have to put that angle, sorry, in brackets. All right, so now we're looking at 90 minus x. Opposite is BC over adjacent is AB. Let's check quickly. As well. And then we're going to get on the test. Okay, guys, I'm actually just going to let you practice more of this on your own for tomorrow. There are 3 other trig ratios, but they are the reciprocals of these ones. Do we know now what reciprocal means? When you swap a fraction around. Okay, but we'll do that tomorrow. So for today, we're just going to practice sine, cos, and tan. You'll see the exercise that I'm going to give you. They've given you various triangles, and they're asking for sine of this angle, cos of this angle, tan of this angle. All right, and we're just going to practice working with these ratios. Okay, so that is exercise. This is now in your full textbook, obviously. Exercise 5.2 on page 105. Numbers 5, 6, and 7. So guys, in number 5 is just one triangle, and they ask you to find the ratios, just like we did now in our triangle. In number 6, they have put like a smaller triangle inside a bigger one. All right, so that's slightly more complicated, but they then tell you which triangle to work in. And then in number 7, they've done the same thing, but they're saying you need to write 2 formulas for each ratio. So you're gonna have to look in the different triangles. Okay. Let's start working on that now. Your Olympiad marks, guys, I don't have the actual answer sheets anymore. I